The Chapter 6 review video. This is Mr. Saari, and I'll be talking through and working through the Chapter 6 review for Precal-12. Alright, so in exercises 1 through 4, we're going to solve the triangles completely, and if there are two solutions, we're going to find them both. So we always start these by setting up a table of our givens. We got A, B, and C, and these are our angle measures. Remember, capital letters are angle measures, while lowercase letters represent side lengths. So we have A is 36 degrees, B is 98 degrees, and side C is 16 units long. So anytime we have two of our three side lengths, anytime we have two of our three here, we know we can find the third angle because these three add to 180. So we do 180 minus the sum of 36 and 98. Those add to 134. 180 minus 134 is 46 degrees. So 46 degrees is the measure of angle C. And now since we have all three angles, we can now use the law of sines to solve for sine B and sine A. A and B in whichever order we prefer. So I'm going to first set sine A, so sine of 36 degrees over side A equal to sine C over side C. So sine of 46 degrees over 16. We want to solve for A, so we're going to multiply by the denominator on each side. So multiply each side by 16 and multiply each side by A. When we multiply both sides by A, essentially some people call this cross multiplying. Really, you're just multiplying by the denominator on each side. So we've got 16 sine 36 equals A times sine 46. Remember, sine 46 and sine 36, those are numbers. Make sure our calculator's in degree mode when we enter this in the calculator. So we solve for A by dividing by sine 46. That reduces to 1, so we're left with A equals 16 times the sine of 36 degrees divided by sine of 46 degrees. And we get 13.07 or 13.1 for A. So we've got A is 13.1. And now to find B, some people might be tempted to use Pythagorean theorem here, but remember, you can only use the Pythagorean theorem, which is A squared plus B squared equals C squared, if we're dealing with a right triangle. And since there is no 90-degree angle, this is not a right triangle, so we cannot use the Pythagorean theorem. So we're now going to use law of sines again, this time using sine B over B. So we're going to set sine of 98 over B is equal to, we can either use sine 46 over 16 or sine A over A, which is sine 36 over 13.1. I kind of like using the ones that were given to me to the greatest extent that I can. So sine 46 over 16. So we cross multiply here again. Multiply each side by B. That reduces our B's. Multiply each side by 16. And we're left with 16 sine 98 is equal to sine 46 times B. And we can divide by sine 46. So we're left with 16 sine 98 over sine 46 is equivalent to B. We can enter this into the calculator. 16 times the sine of 98 divided by the sine of 46. And we get that B is 22.03, which we can round to the nearest tenth as 22.0. So our solutions for this on our so find the solutions, we found all of these right here. Okay. So on to number 2. All right, number 2, just taking a quick look at it, we see that we have 3 sets of givens, or 3 given attributes. They're all side lengths this time. So we make our chart of givens, just to organize our information. We have no angles, but we have all the side lengths. We have A equals 2, B equals 4, and C equals 5. Okay, so I didn't mention in the first triangle if we should search for a second triangle or not. Remember, you check for a second triangle when your givens consist of one complete set plus one other side. So essentially, if you've got a side and its corresponding angle along with one other side, that's when we would need to check for a second triangle. And I'll show you that with one of these down here, I'm sure. So, got our givens set up. We're good to go there. I'll do all the work in different color now. Let's pick this interesting pink color. Okay, so when we've got, notice here we don't have a complete set. We don't have a side and its corresponding angle. Remember, that is the prerequisite for using the law of sines. Remember, law of sines is sine A over A equals sine B over B equals sine C over C. So we can't use this because we don't have any angles. So we got to stick with the law of cosines. And it doesn't matter, there are 3 versions of the law of cosines. Remember, we got law of cosines here, law of sines here. So law of cosines, recall, we've got 3 different versions. So we're going to use, doesn't really matter which one, so we're going to start with this one, the one that starts with A and ends with cosine A. So we're going to set A squared equal to B squared plus C squared minus 2 times B times C times the cosine of angle A. So notice our unknown here is going to be angle A. We're solving for this one first. Okay, so let's solve it. So we substitute everything in. We got 2 squared equals 4 squared plus 5 squared minus 2 times 4 times 5 times the cosine of angle A. So 4 equals 16 plus 25 minus 2 times 4 times 5, that's 8 times 5, which is 40, cosine A. So now, notice a mistake people commonly make is they'll combine the 16, the 25, and the 40 here. Okay, my son just walked up, 6 in the morning on a Sunday, and my son just walked up. So if you hear any noises, that's what it is. Luke, you can play with that, that's fine. I'm going to need that back though in a second. Why don't you play with this instead? I need my calculator back, okay? Okay, sorry. So we've got 4 equals 41 minus 40 cosine A. Again, we cannot combine those because they're not like terms. 40 is multiplied by cosine A while 41 is not. So our next step is to subtract 41 from each side. So we got negative 37 equals negative 40 cosine A divided by negative 40. And we have 37 over 40 equals cosine A. I made that positive since 2 negatives divided by each other is a positive. And now I can take the inverse cosine of each side to get A by itself. So we plug that in the calculator. Hit the wrong button there. All right, so we are going to do inverse cosine of 37 over 40. So second cosine, 37 divided by 40. And we get 22.3 degrees. So 22.3 degrees is our solution for angle A, 22.3 degrees. Okay, now it's time to find angle B. So angle B, I'll switch colors. And we're going to use the same formula again. Except this time you're going to use the different version of it that starts and ends and includes angle B rather than angle A. So here we go. We got B squared equals A squared plus C squared minus 2 times A times C times cosine B. And again, you can find this formula down at the formula sheet at the end of this review guide. So now substituting in. Now, pause for a moment. Some of you might be wondering, why aren't we using the law of sines? We have a complete set. Now we can use the law of sines. So on some occasions, the law of sines will lead you astray here. There is a way where you can use law of cosines and then transition to law of sines. But the only way you can do that is if you use the law of cosines first to find the angle that corresponds with the longest side. So as a general rule, I just say once we start with the law of cosines, stick with it until you can finish the problem. So don't want to mix your methods. All right, so B squared. So we got 4 squared equals 2 squared plus 5 squared minus 2 times 2 times 5 times cosine of B. 16 equals 4 plus 25 minus 20. That's 2 times 2 times 4. 20 cosine B. Combine these and subtract. So subtract 29 from each side. Negative 13 equals negative 20 cosine B. Divide by negative 20. And now we've got 13 over 20. Whoops. 13 over 20 equals cosine B. And I can take the inverse cosine of each side. And we do the inverse cosine of 13 over 20. And we see that it's 49.5 degrees. So 49.5 degrees. So B equals 49.5 degrees. So we found B to be 49.5. And now we can finish this off, finding our third angle. We could use the law of cosines again, but there's an easier way. Remember, when we have two sides, we know the third has to, The third we can find by knowing that the sum of these three is 180. So we can do 180 minus the sum of 22.3 and 49.5. And we get 180 minus, what is that? 61.8. So we get 118.2. So 118.2. That does not seem right. Let me see here. Okay, looks good. All right, very good. So moving on to number 3. All right, so we've got number 3. So looking at this one, so setting up our table. So A equals, B equals, and C equals. And sides A, B, and C also equal. So we've got side B is 8, side C is 12, side angle A is 35 degrees. All right, so we've got our givens all set up. So one thing that I'm thinking here is that we don't have a complete set, so we cannot use the law of sines. We also know that the law of sines, that we don't need to worry about a second triangle because our givens would have to be a complete set plus one other side for that to be in play. So no need for us to check for a second triangle yet. All right. So I see we don't have a complete set, don't have a side and its corresponding angle. So we're going to have to use law of cosines here. And there's only one particular version of the law of cosines that's going to work because we're given an angle measure. So we have to include the one that, we have to use the one that includes the angle that we're given. So we're going to need to use this first version of the law of cosines. So we're going to have to use the version of law of cosines including a. So we've got a squared equals b squared plus c squared minus 2bc cosine a. So a squared, that's our unknown, equals b squared, that's 8 squared, plus 12 squared minus 2 times 8 times 12 times the cosine of angle A, which we now know, which is 35 degrees. The nice part about this version is that A is essentially already isolated. All I'm going to have to do is simplify everything on this right side and then take the square root. So a squared equals, I'm going to go ahead and plug all this in the calculator. So we've got 8 squared plus 12 squared. So I've got 8 squared plus 12 squared minus 2 times 8 times 12 times the cosine of, forgot what the angle was, 35 degrees. So times the cosine of 35 degrees. And we have that. So we get 50.7 or so. So we can go ahead and write that in if we'd like. Roughly 50.7. But again, we don't want to round that because when we take a square root of something rounded, it's going to throw off our solution by a little bit potentially. So we want to make sure we take this, when we take the square root here, we take the square root of not just 50.7 but this entire answer, just for accuracy standpoint. So we get 7.12 as our answer. So when we square root that, we get a equals 7.12. So if we round nearest tenth, we get 7.1. Okay. You know, now that since we're going to use this to solve for other angles and sides, I'm going to go ahead and leave it at 7.12. Okay. So, following my general rule of when we've started with the law of the cosines, sticking with it is never a bad idea because you'll never be led astray here. But because we know, so we want, once we've started with the law of cosines, we want to stick with the law of cosines. So we're going to use the law of cosines to find angle B here. So we're going to set up another set of law of cosines, but this time we're going to use the one that involves angle B. So it's going to be b squared equals a squared plus c squared minus 2ac times the cosine of angle B. So b squared, we got 8 squared. A squared, remember that was 7.12 squared. 7.12 squared plus c squared, and that's 12 squared, minus 2 times a, that's a 7.12, times 12, times the cosine of angle B. All right, so we're going to simplify some of these. So we got 64 equals, remember if we look back at our calculator, 50.72 was 7.12 squared. So 7.12 squared, just proving it. 7.12 squared, 50.7. So we go back to here, we got 50.7 plus 144 minus 2 times 7.12 times 12. Again, calculations here. 2 times 7.12 times 12. 170.88. So we've got 170.88 times the cosine of b. So we combine these, subtract them. So we subtract, those combine to 194.7. So we subtract 194.7 here because of those two from each side. And we get negative 130.7 equals negative 170.88 cosine b. Divide by negative 170.88. And then that's going to, whatever that is, will equal cosine b. So we got cosine b equals 130.7 over 170.88. And then we're just going to take the inverse cosine of that to solve for b. So inverse cosine of 130.7 over 170.88. Let's put that in the calculator. Second cosine for inverse cosine, 130.7 divided by 170.88. And we get 40.1 degrees. 40.1 degrees. So B equals 40.1 degrees. So we've gotten angle B, it's 40.1. And now for C, we can just subtract from 180 to find side C, or angle C, excuse me. So we know we can take 180 and subtract the sum of 35 and 40.1. So 180 minus 75.1, we get 104.9. So 104.9 degrees. So those are our solutions for number 3. All right, on to number 4. Okay, so for number 4, let's go with black. Okay, so number 4. All right, so we set up our charts. So we have sides A, B, and C. So angles A, B, and C, and sides A, B, and C. And when we fill in our givens, one thing, we're going to notice something special here. So based on our givens, because we have a complete set, essentially an angle and its corresponding side, along with one other side, this is that special circumstance where we need to check for a second triangle. So we're just going to make a second chart that's identical to the first, and we're going to fill in our givens just as we did. So here's our possible second triangle. Here's our possible second triangle. Okay. So this problem proceeds like any other. This problem proceeds like any other, except when we find this first angle using the law of sines, we're going to have to then transfer our answer over here in a special way. So first thing we do is we're going to use the law of sines to solve for angle B. So we've got sine A over A equals sine B over B. So we've got sine of 25 over 18 equals the sine of angle B over 28. We can multiply both sides by 28 to isolate sine B. And then we're going to take the inverse sine of each side to totally isolate B. So we have the inverse sine of 28 sine 25 over 18. So we're going to enter that into our calculator. Inverse sine of 28 sine 25 divided by, I forgot what it was, 18. Divided by 18. All right, so we're entering that in the calculator and we get that. The first angle we can find is 41.1 degrees. So angle B is 41.1 degrees. So that's what we get, and that's what we put in our first triangle here. Now, here's the somewhat tricky part. As soon as we find that first angle, the very next thing that we do is we transfer that answer to our second triangle in angle B, but instead of putting exactly the same thing, we're going to put 180 minus what we just got. Okay, so 180 minus 41.1. So we get 138.9 degrees. And that's what goes in to our second triangle. So that's the only time these two triangles interact. And now we solve them both separately. So I'll use this pinkish color, pinkish purple, to solve the rest of this one. So for the rest of this one, we know whenever we have two angles, we can solve for the third angle by subtracting from 180. So I'm going to do 180. Actually, let's do it right over here. So 180 minus 25 plus 41.1. That's 180 minus 66.1. So it's 133.9. So at 133.9 degrees here. Okay, so 133.9 degrees, and then side C, I can just find using the law of sines. So we set sine of 133.9 over side C is equal to the sine of 25 over 18, just sine A over A there. So we cross multiply, and I have 18 sine 133.9 equals C times the sine of 25. So I now divide by the sine of 25. And I get that C equals 18 times the sine of 133.9 over sine 25. So 18 sine 133.9 over sine 25. And we get 30.7 degrees. So, sorry, C equals 30.7 units long. Okay, so 30.7. And now we've completely solved our first triangle. That one works. And now we have to completely solve our second triangle. So I'll change this color to this nice little purpley blue color. So remember, just like I did when anytime I have two angles, I can find the third angle by adding these together and subtracting from 180. So I'm going to do 180 minus the sum of 25 and 138.9. And again, that's 180 minus 163.9, which is 16.1 degrees. So 16.1 degrees for this angle C over here. Notice how these are not really related, right? They don't add to 180 like angles B and B did. That's the only place where that relationship is true. Okay? And now we're going to finish off by finding little c, side C, by taking the sine of 16.1. Again, we're using the law of sines here. I'm setting sine 25 over 18. All right, so again, we multiply both sides by c. Again, we're cross multiplying here. Times 18 times 18. So I've got 18 sine 16.1 equals c times sine 25. We can finish this by dividing both sides by sine 25. This reduces to 1. Here we're left with c equals 18 sine 16.1 over sine 25. 18 times the sine of 16.1 divided by the sine of 25 degrees. And we have 11.8. So c equals 11.8 degrees. Not degrees, 11.8 units since it's a side length. All right, so 11.8. Okay, so all right, on to number 5. So we have to find the length of the pond shown. Find the length of the pond shown. So for this one, we need to, it's kind of like a triangle application problem. And the important skill that you need here is to be able to recognize that angles and sides across from them are corresponding. So essentially by saying find the length of the pond shown, we're looking for what is the length of side A here. Because remember, if this is angle C, this would be side C. And if this was angle B, this would be side B. So again, this is as if we were given a triangle knowing angle A, which is 80, and then we don't know angles B or C, but we were given side B, which is 480, and side C, which is 565. And these are both measured in feet. Okay, and it's saying solve for the length of the pond. That's side A, and that'll be measured in feet. So notice if we set it up like we always do with a chart, we can recognize, all right, we don't have any complete sets of anything, so law of sines is out. So we got to use the law of cosines that includes this angle. So we're going to be done when we solve for side A here. So let's solve for side A. A squared equals b squared plus c squared minus 2bc cosine A. So I've got a squared, that's what we don't know, that's our unknown, equals 480 squared plus 565 squared minus 2 times 480 times 565 times the cosine of 80 degrees. So I can simplify all this. I can even go ahead and just take the square root of it. I'm going to put all this in the calculator, including the square root, and it'll give me side A. So let's put this in the calculator. So we've got the square root of 480 squared plus, I forgot what it was. What was it? 480 squared plus 565 squared minus 2 times 480 times 565 times the cosine of 80 degrees. So that's the cosine of 80 degrees. Close our parentheses, hit enter, and we get, and that's, remember, that already includes the square root. So that's 674.9. 674.9 feet. And that would be the length of our pond. 674.9 feet. Okay. All right. Last question on this first half of the review. We've got a triangular parcel of land whose borders have lengths of 55 meters, 85 meters, and 100 meters, and we want to find the area. So for this one, notice how we're given 3 sides and no angles. So to find the area of this, we're going to want to use Heron's area formula, which is area equals the square root of s times the quantity s minus a times the quantity s minus b times the quantity s minus c, the square root of all that. where S is 1/2 times the sum of A, B, and C. Okay, so again, just applying the formula. We have, remember, this is A, this is B, and this is C. It doesn't really matter which is which. So we've got, first we'll find S. So it's 1/2 times the sums of A, B, and C. So it's 55 plus 85 plus 100. So it's 1/2 times 240. So S is 120. So S is 120. So now we can apply our formula. So area is capital A. I'm just going to write area. So area equals the square root of S, which is 120, times S minus A, so that's 120 minus 55, times S minus B, so 120 minus 85, times S minus C, 120 minus 100. So we can simplify this and put it in the calculator, or put in the calculator just like this. I'm just going to simplify a little bit. 120 times, is that 65? So 120 times 65 times 35 times 20. So I'm going to put that in the calculator right there. So we got the square root of 120 times 65 times 35 times 20. So we hit our answer here, and we have 2336.7, and that would be the area. So area equals 23, was it 66? 2336. 2336.7 meters squared, since it is an area. And there we go. That concludes the first half of this chapter review.